Alrighty, welcome back. We are going to jump past section 7.4 and we are going to go to 7.5. This is actually going to be the last section that we cover before we do our test/quiz on chapter 7. So let's go ahead and jump right into it. This lesson is about ratios and triangles, and sometimes we'll be looking at just parallel lines and ratios as well. So the start thinking part says, look at the following triangle. Try to come up with a conjecture, which is kind of like a hypothesis, about the lengths of the segments created when a segment is created inside a triangle with endpoints on the triangle such that the segment is parallel to one of the sides. That was super confusing. All that was basically saying is if you have a triangle, we're talking about a segment that is inside of it and is going to be parallel to that third side. So when we're looking at this isn't necessarily a mid-segment like we've been dealing with before. This is just any old segment. We're trying to figure out what kind of ratios we have. Now, here is the spoiler. There are a bunch of different ways that you can set up this ratio. Let me go ahead and show it to you. We can do this over this equals this over this. So what that would be bottom over top equals bottom over top. 1/3 is going to equal 3/9. Another one would be top over bottom equals top over bottom. Okay? Now let me show you another way that we can do this. You can also have top left over top right equals bottom left over bottom right. That's another ratio you can set up. And then another one can be this length over the whole equals this length over the whole. Let's make sure that actually works. 3 over the whole, which is 4, equals 9 over its whole, which is 12. And that also reduces to 3/4. Basically, the deal with these ratios is that there are very few ways to mess it up. How can you mess it up? Well, obviously we can see we cannot put that over that equals this over this. That is one way to mess it up. Okay. Another way would be we cannot say bottom over top equals top over bottom. That ratio does not work. Let's go ahead and just actually look at the theorems and solve for some unknowns, because right now we're looking at a triangle that has no unknowns. If we have this, the theorem says if a line is parallel to one side of a triangle and intersects the other two sides, then it divides the sides proportionally. And once again, I was looking at those proportions before. If we wanted to look at just one of them, we call that A, B, and C, and D, then one of them would be A over B equals C over D. Okay. So if we take a look at these ones, which have unknowns, we have this segment. It is parallel to this one, so it goes along with our theorem. I'm going to do that over that equals this one over that one. And now that we've set it up, we can actually go ahead and solve it. 2 times 9 is 18. 6 times x equals 6x. And then when we solve, you get x equals 3. Right? As I said, this could have been set up a different way as well. This also could have been 9 over 6 equals 2 over x. And you would have gotten the same exact answer. And by that, I am wrong. Let me look. 9 over 6 equals 2. Oh, sorry. This is why I was wrong. 9 over 6 equals, it's not 2 over x. It would be x over 2. Okay. One way you cannot do it is just going around the figure like that. That's what I accidentally did. I said 9 over 6 equals 2 over x. You kind of have to bounce over the figure. So let's go ahead and do this one right here. I am going to do it top over top equals bottom over bottom. And when we do that, you end up with 16x equals 7 times 16. 7 times 16 is 112. And then you would divide by 16 and divide by 16, and you end up with 7. There you go. So the next one is a little bit more complex. I'm going to warn you that sometimes we get into some hairy algebra, meaning sometimes you even end up with a quadratic and you're going to have to solve that using the quadratic formula or solving by factoring. So if I did this one, I'm going to call that the top of the triangle. So x minus 1 top over bottom equals top over bottom. I think this one might actually come out to be a quadratic. Let's take a look. So when you go over and multiply these ones right here, you end up with 3x squared minus 6x. We're always hoping that the x squared is going to get canceled out somehow, but I don't think it's going to. If we do that one times this one, remember, if you have a binomial times a binomial, you actually have to FOIL it. So x plus 4. If I FOIL this, I get x squared plus 4x minus 1x minus 4. That's going to give me x squared plus 3x minus 4. Now, hopefully when I get everything on one side, the x squareds go away. Not so lucky. Minus x squared. So we're going to end up with, and I'm going to scroll down, but then I'm going to white it out in a minute. If I did this, I would have 3x squared minus x squared. That gives me 2x squared on the left. Then I would do minus 3x minus 3x, and that gives me minus 9x. And then plus 4 and plus 4, that's add 4. Now since we have a A term and we have a B term, I'm going to solve this. You know what? I feel like doing the quad formula. Let's do the quad formula. X equals negative b, because negative 9 is 9. X equals negative b plus or minus the square root of b squared minus 4ac all over 2a. That gives me 9 plus or minus the square root of 81, and then minus, let's see, 4 times 4 is 16, times 2 is 32, minus 32. All over 4. It gives me 9 plus or minus the square root of 81 minus 32 is 49, all over 4. 9 plus or minus, what is the square root of 49? 7, all over 4. And that gives me 9 plus 7, which is 16 over 4, and 9 minus 7, which is 2 over 4. That gives me 1/2 and 4. That is as crazy as it gets. If you set this thing up and you end up with a quadratic and you have to solve it, you might have to do quad formula or factoring. I knew that I wanted to just try out the quad formula because I didn't feel like factoring. So that's how I got those two answers. And you could always check your answers as well. Let me go ahead and white this out. All right, let's move on to the next problem. It says, what do you notice is true when multiple lines are cut by two transversals? So this is going to be the same exact thing. There's going to be several ratios and proportions that you can work with. We could do top over bottom equals top over bottom. That will give you the same thing. You can do bottom over bottom equals top over top. I think it's probably easier to tell you what you can't do. Go and do crosswise, so 4 over 30 equals 6 over 20. That's not going to work. The other thing you cannot do is go in a circle. So you cannot go over and say 4 over 20 equals 30 over 6. It's got to be like bouncing. So bottom over top equals bottom over top, or top over bottom equals top over bottom. So let's go ahead and move on to the next page. So basically, if we have this right here, it says if three parallel lines intersect two transversals, then the segments intercepted on the transversal are proportional. Meaning if I called this, I know that we've already have A's and B's. Let's do M, N, K, and P. This would be one way we could do it. Top over bottom equals top over bottom. There's many other ways as well. So let's go ahead and do a problem. I would actually like you guys to try this one. Go ahead and try this problem and see what you get for X. All right, I'm going to do top over bottom equals top over bottom. Then I'm going to cross multiply. I get 30 equals 3x. Divide by 3, and you end up with a 10. Okay. Now I'm getting a little worried here. I don't know if you guys are looking at this, but it looks like there's a lot of x's, and I'm thinking we might end up with a quadratic. Let's give it a shot. Top over bottom equals top over bottom. Ooh, maybe we won't end up, we'll see. Anyways, x times 9 is 9x. That times that, we are going to have to FOIL that. X plus 4 times x minus 2. You get x squared minus 2x plus 4x minus 8. That gives you x squared plus 2x minus 8. Ugh. Okay, so we're always hoping that the x squared will go away and we won't have a quadratic. Not so lucky. Minus 9x minus 9x. You end up with 0 equals x squared minus 7x minus 8. Whew. Remember, you can solve quadratics by graphing, by factoring, and by the quad formula. I'm going to go over and do this one by factoring now. So let's do our ACB chart. A times C is -8 and B is -7. Two numbers that multiply to get that and add to get that, -8 and 1. So what I do, remember, we can do the shortcut because there is no number in front of the x squared. By default, it's just a 1. So what I can do is I can jump straight to saying x minus 8 and x plus 1. Okay. And then when we go over and solve this, equals 0. When we set that one equal to 0, x minus 8 equals 0. You get x equals positive 8. And then when you set that one equal to 0, you get x equals -1. Now there's one thing that I forgot to tell you guys about. And what that is when you solve, you're supposed to check your answer to make sure that it makes sense and it's not extraneous. Extraneous means you did everything right, but you got an answer that doesn't make sense for the problem. Now, which one of these, A or B, looking back at your original figure, makes no sense for our problem? That one would be extraneous because a side length cannot be -1. We actually look back up here, let's see. If we look at this one right here, I think, what were the two answers we got? Oh, remember we did it down here. Anyways, look back. I don't know what the answers are because I erased them, but take a look at your two answers and ask yourself, are either of those answers we got for this, did they not make sense? Is there not necessarily a negative number is not necessarily always extraneous. For example, like -1 doesn't make this part not make sense because -1 plus 4 is 3, and you can have a side length of 3. But -1 would not work for this, so it would be extraneous. So look at our two answers that we got and see if either of them just don't make sense for our problem and see if they are extraneous. We'll cover this a little bit more in class, extraneous solutions. But just as a real quick reminder, extraneous solutions are answers that you get and you've done everything correctly, but they just don't make sense for your problem. All right, we got this one right here. Basically what it is saying is if a ray bisects an angle of a triangle, then it divides the opposite side into two segments that are proportional. to the other two sides. If I call this x, y, z, and w, basically there are many different ways that you can set this up again. I'm going to set it up as x is to w as y is to z. All right. So let's go ahead and run through some of these problems. On this one right here, I'm going to set it up as, actually, let's go ahead and have you do this. Go ahead and set up your proportion and solve and see what you get. All right, the way that I'm going to set it up is 16 is to, and you should get the same answer if you set it up in a equivalent way, but 16 over 12 equals x over 9. I would get 12x equals 9 times 16. 9 times 16 equals 144. You should get x equals 12. If you set it up, let's make sure that it works if we set it up a different way. 16 top over bottom equals top over bottom. That gives you 12x equals 144, and you still get x equals 12. All right, let's do this one. It's probably going to be another funky one. I'm going to set it up as x plus 4 over x. This over that equals this over that equals x plus 2 over 3. You would end up with that times that. 3x plus 12 equals that times that, x squared plus 2x. Once again, it would be fantastic if we had an x squared on the left as well. That would cancel out the one on the right, but we don't. So let's get everything to one side. We're going to have an x squared on the right. When I subtract a 3x and subtract a 3x, we end up with negative 1x. Subtract 12 and subtract 12, we end up with this. It is a quadratic. We can solve it by factoring, graphing, or by the quad formula. Since there is no number in front of the x squared, and I know I can do the shortcut factoring, I'm going to do that. A times c is negative 12, b is negative 1. Two numbers that multiply to get this and add to get that. Negative 4 and 3. That is the only part that's kind of a guess and check. At that point, since I can do my shortcut, I can go straight to x minus 4, x plus 3. When I set that equal to 0 and solve, I get 4. When I set that equal to 0 and solve, I get negative 3. Are either of those extraneous, meaning they don't make sense for our problem? That one's extraneous. It makes no sense for our problem because you cannot have a side that is a negative length. All right, let's see what we have. Give me 1 second. It says that is all we have. Hopefully that matches with what your notes are. So I'm going to do just a real quick recap. I want to remind you of the different things we looked at. We looked at if you have a triangle and you're looking at something that doesn't necessarily have to be a midsegment. It is just kind of like a midsegment in that it's parallel to that third side, but it does not have to be perfectly in the middle. If you have A, B, C, and D, there are many ways to set this up. You could say A over B equals C over D. That's one way. You could say A over C equals B over D. That's another way. You could say B over A, bottom over top equals bottom over top. That's another way. You could actually, I don't know why you'd ever do this, but you can say top over the whole equals the top over the whole. It's not a D, it's a D, not a B. This one you're almost never going to use. That one doesn't make any. We usually use these ones. So very few ways to mess up. Just don't go crosswise and don't go all the way around the figure like this. B over A equals C over D. The other one we looked at is if you just had parallel lines. These are also going to be divided proportionally. And then we also looked at if you have a triangle and then you have an angle bisector coming down. So that's an angle bisector, and we call that A, B, C, and D. Then you could set this up as A over B equals D over C. You could also set it up as A over D equals B over C. And there are a few other ways you could set that up as well. So anyways, hopefully that makes sense. If you guys have any questions, make sure you ask them in class. I think the most difficult part here is when you go over and have binomials, which are the lengths of the sides, and you end up with a quadratic and have to solve by the quadratic formula or factoring. And then remember that last step, look for extraneous solutions. See if there's any number that just doesn't make sense for your problem. Thanks so much for watching.